Find the tangent and normal in sketch. X squared plus 25y squared equals 50 at the point minus 1 7/5. So let's have a go at this then. Let's do a little sketch first of this ellipse. So when y is 0, you can see that x squared is 50, so you've got root 50, which is 25 times 2. So that's 5 root 2 when you square root, isn't it? 5 root 2. So let's put that here. 5 root 2, and then minus 5 root 2. That's root 50. So we can see that easy. When y is not, x squared is 50, so we square root, we get root 50s. That's fine. When x is 0, we get y squared times 25 is 50. Move the 25 under, and we can see that y squared is 50 over 25, which is 2. Square root, you get root 2. So it's quite a flat ellipse, isn't it? But we'll put the scale here so we can adjust the scale so we can draw it more easily. So we've got an ellipse like so. There's our ellipse. Not very well drawn. I'll go have a quick another go at that. Comes up here, it's flat. It's a little bit better. So there's our ellipse then. We want minus 1 and 7/5, which will be here. I'll label that P. I'll get rid of this coordinate here, because I want to specify the point. So this point here is minus 1 and 7/5. So the tangent will be fairly flat, won't it? But for the purposes of the sketch, I'm going to draw it not quite as flat as it should be. So I'm going to come over here and just draw it down like so. But it should be flatter than that, really and truly speaking. And then I'm going to draw the normal, which I'm not going to draw that normal. I'm going to come over here and draw that normal, say, like so, and draw it like that. Not very well drawn, I know, with a digital pen, so got my excuses ready. So here we are then, let's have a look at this. This is the tangent at the point, and this is the normal. Okay, so what have we got then? Let's differentiate term by term. So here, differentiating gives see what we've got then. 2x, first term. Second term, it's going to be 50. The 2 comes down to be with the 25 to make 50. Y to the 1 power less, which is 1, multiplied by the something differentiated. And then the constant here goes to 0. So y dash then is equal to, move this 2x over, and then we can divide by the 50y once it's moved over. Cancel 2 top and bottom, minus x over 25y. So there's our gradient function. So tangent then, so we better work out the gradient at the point then, minus 1 and 7/5. Y dashed is equal to minus 1, which is plus 1, over 7/5 in here. 25 times 7/5, so 5 will cancel, and we're left with 7 5s are 35. Very, very shallow, positive, which is what we said, didn't we? Our sketch doesn't quite allow us to put in such a shallow gradient, really. So we've got that, which looks good. Let's just double check then. X was minus 1, so that was plus 1. 25 times y, 25 times something, so that's 5 7s, because one of the 5s cancel. 5 7s is 35. So the tangent then is y minus the y value, which is 7/5, is equal to m, the gradient, 1 over 35, times x minus the x value at the point, which is minus 1. Double minus makes it a plus, so there's our tangent, and the equation of the normal, and that would be y minus 7/5 again, and the x value would be x plus 1 again, but instead of that we'll have minus 35. Very, very steep. here, which is what we've got. The intercept would be minus 35 plus 7/5. So it's actually way down here. Much more steeper. So this inside the ellipse is not correct at all. This should be much more steeply drawn in the sketch, really and truly speaking. But we've got such flat lines, it's hard to illustrate that in the actual limited area we've got.